All right, welcome back to 5.4 day 1. If you want to start off by naming the transformations, I know it says graph. If you want to just practice naming your transformations, take a second, pause the video, and let me know what the transformations that happened to that equation were. Okay, now that you paused, you tried it out, you should have said left 3 and down 2. Those are the two transformations that happened in that equation. So today in this one, we are going to be using radicals, but solving with them. So it's going to be a lot of very similar to Algebra 1 solving, with some other things thrown in there now that we have roots in there. Okay, so looking at this first one, we're trying to get that x alone. First thing I would do, since we just have one square root, now we're going to level up and we're going to have 2 square roots or something else. Right now, we're going to get that square root alone. So I'm going to do that by adding 1 to start. So that square root needs to be on the side all by itself. Nothing else over there except the square root. And now over here we got a 4. We did this because to get rid of a square root, we're going to do the opposite. Normally, we've had x squareds. So to get rid of an x squared, we square rooted. So to get rid of a square root, we are going to square both sides. So when doing that, it just got rid of that, leaving me with an x plus 5. And we know that 4 squared is 16. Looking fabulous. Now all we need to do is get rid of plus 5. So I'm going to subtract 5 on both sides, giving me x equals 11. And there is my solution. All right, let's try another one. On this one, we already have that root on one side by itself. So to get rid of it, we are going to do the opposite. Since it's a cube root, I am going to cube both sides. So now this is gone, leaving me with x minus 1. And 2 to the 3rd power is 8. Now I can just get rid of that minus 1 by adding 1 to both sides. And my answer is positive 9. All right, let's look at this one. We have the square root on one side by itself. Awesome. So to get rid of it, we are going to square both sides. Ooh, this one's a little trickier. So now I got rid of that, leaving me with 3x minus 2. On the other side, though, it was an x minus 4 squared. We know something squared is that thing times itself. So we got to multiply it out. Let's do that. X times x, I'm going to do it over here so I have it simplified. X times x would be x squared. X times negative 4 would be negative 4x. Negative 4 times x would be negative 4x. And negative 4 times negative 4 is a positive 16. So I can put those like terms together in the middle. So I have an x squared minus 8x plus 16. Now this one has a lot more. We have an x squared when we're going to solve this. So whenever we have an x squared, I would set it equal to 0 from here. So I'm going to move this stuff over actually. I'm going to subtract 3x on both sides. And I'm going to add 2 on both sides. So now I have 0 over there. Let's put some stuff together. Negative 8 minus 3 would be negative 11. And 16 plus 2 would be 18. All right, now we got to solve by factoring. I'm sorry, factoring never goes away either, just like transformations. So we want two numbers that multiply to be 18, add to be negative 11. So that would be x minus 9 and x minus 2. To get those solutions, we need to set each of those equal to 0. So I'm going to take x plus 9, set it equal to 0, which gives me an answer of negative 9. Also set this one equal to 0, which would give me positive 2. So here are my two solutions. Now, we do have to check our solutions on these ones for an answer that doesn't actually work. So if you notice, we had this square root, and we know we can't have square roots with a negative underneath. That's imaginary. We don't want that as a solution. So if I were to plug each of these answers that we got in there, so 3 times negative 9 minus 2, that would give me a square root of a negative 27. So that answer of negative 9 is not possible. But if I plug in my other answer of positive 2, that would give me a square root of 4. And that's okay. We can have that, but we can't have that square root of a negative. All right, last example for today. Let's look at this one. We already have a square root all by itself on that right side. So I'm going to square each side to get rid of it. Now again, it's a little more tricky because we got x plus 2 squared, which is times itself. So let's multiply it out on the side to give us a little extra boost. X times x would be x squared. X times 2 would be 2x. 2 times x would be 2x again. And 2 times 2 is 4. Which we can put those like terms together. X squared plus 4x now plus 4. And we got an x squared in here. So to solve this, we're going to start by setting it equal to 0. So this time, since the x squared's on this side, I'm going to move that stuff over. So I'm going to subtract x. And I'm going to subtract 2 on both sides. So now we got 0 over there. It doesn't really matter which way the 0 goes. I just don't want the x squared to be negative because of factoring. So x squared, 4x minus a 1x would be 3x. And 4 minus 2 would be 2. Okay, so let's think of two numbers that multiply to be 2, add to be 3. That would be 2 and 1. So I'm going to set both equal to 0 to give me my solutions. So the first one gives me negative 2. And the next one gives me, negative 1. Let's check each of our solutions that we just found to make sure we don't have a negative underneath this square root. So let's plug in each one. Square root, I'm going to plug in negative 2 plus 2. That would give me a square root of 0. That's okay. We can have 0, just not negative. And if I plug in negative 1 plus 2 would be a square root of 1. So both of our answers on this one are okay.